Writing an equation for an exponential function. There's two main components when we're talking about writing an exponential function. One of the things that we want to find is the initial value, and then we want to find the growth or decay factor. So in this problem, the first thing I'm going to look at is the initial amount or the initial value. So this has a y-intercept of 2. And so my initial value is going to be 2. That's important. Initial amount or initial value. Okay. And then we're going to look at the pattern. We're going to see if we can figure out a pattern. So we're here at 18, and then we move 1 over, and then we're at 6, and then we move 1 over, then we're at 2. After that, it gets a little harder to read. But this is between 0 and 1 somewhere, so some fraction. It's actually 2/3. And then we have another fraction, which is actually 2/9. So if we got 18 to 6 to 2, even if we ignore these 2 points over here, we can figure out what's happening, right? 18 divided by 3 is 6. 6 divided by 3 is 2. But with exponential growth, we don't want to think dividing, we want to think multiplying. What are we multiplying by to get, to the next point? And we're multiplying by 1/3, right? This is a decay factor. It's getting smaller. So that number is between 0 and 1. That number is 1/3. So this is a decay factor. And then we got 1/3. Okay, so what our equation is going to look like, assuming there's no other crazy transformations here, is it's going to be f of x is equal to the initial value times the growth or decay factor, and then we have our power here. Okay, so this is what we're looking for, and we got a few different answer choices. So we have these 4, and then we have this last one here. So the one that it's going to be is this guy. That may be in a different order in the problem that you did, but the answer choices should be the same. We want 2 times 1/3 to the x power. So that's kind of what we're going to do there. Just a couple other things is how we know that this hasn't been like translated or like shifted. We have our asymptote that is still here at 0. So that means it hasn't been, shifted up or down or anything. It does look like it's been reflected over the y-axis. That's because we have this fraction here, and it's not flipped over the y-axis, of course. So the one you're going to have on your test, it could be a growth or it could be a decay, but it's not going to have, the graph part is not going to have too many transformations. Now there will be other problems where you do have to identify transformations, but there's not going to be, too many weird things going on in your graph. You pretty much want to find your initial value and your growth or decay factor.